Hi, can somebody acknowledge whether my screen is visible?
Yes, it is visible.
Yeah, yeah. Thank you. Thank you so much. Okay. So today's agenda for this session is to revise some concepts of week five of LLM. So week five of LLM basically deals with the tokenizers, various techniques used to tokenize. So why do we need a tokenizer? So once we have got, for example, some corpus, I'll just give an example. Uh, a small example I enjoyed while going for a walk, enjoying scenic beauty was exhilarating. So this is kind of like we get a corpus. So what do we do? First step, we build a workup, and then from that workup, once we are passing the sentences, we pass the tokens in that sentence. Pass the tokens. So main challenge is building this vocabulary from a corpus. So the professor he explained it two ways. First is that we have got entire corpus and we use only the this space delimiter. That wherever there is a space, use it. But the main disadvantage of this is that your vocab size, which is it becomes very large. It becomes large. Why it becomes large? Because the words like enjoy, enjoyed, enjoying, they are different tokens in this. Number one. Number two, if an unknown word comes, then it doesn't know how to handle challenges. Okay. Number three, there are certain languages they don't have white spaces. So these are the main challenges for a white space vocabulary building. The second choice is that we only select the characters only. So in that challenges that the vocab size become very small. Okay, we'll have for example A B C D, small A B C D. If you're not normalizing 0 to 9, some special characters, then it becomes very small. So from that we get an idea that we have to these are the challenges in the building a vocabulary. What should be the size of a vocabulary? Larger the size of embedding matrix, the greater the computation of softmax probabilities. So your white space is a bad option. If we limit the size of the vocabulary, then we need a mechanism to handle out of vocabulary words. How do we handle them out of unknown words? Handling misspelled word in corpus and open vocabulary problems. So from there, we arrived that we have to use something between the word space and the character space. So this is the diagram that from the character level and this is the word level, we have to do something in between, subword level. So in the subword level, presently the techniques which are available, one is byte pair encoding, second is word piece encoding or word piece technique, and the third is sentence piece technique. Is everything clear till now? The advantages, disadvantages, what we have covered till now? Any question?
No, thank you.
Yes, thank you.
Yeah, okay. So we go further. So then we come to byte pair encoding. And how do we do it? Because the question, if it will come like the GA, it will come how to do it. Okay. So in the byte pair encoding, what do we do? This is the algorithm, simple algorithm. Start with a dictionary that contains words and their count. So this is the first part. Append a special symbol, this slash w at the end of each word in the dictionary. Set required number of merges as hyperparameters, how many merges you need. So this will explain further also. Initialize the character frequency table, a base vocabulary. Get the frequency count for a pair of characters and merge pairs with maximum occurrences. So how do we do this? So from the lecture only, I've taken this example. The corpus is like knowing the name of something is different from knowing something. Knowing something about everything is not bad. So this is a full stop here. Okay. So what do we do? First step, we make the dictionary that contains words and their counts. So we start with every word. So knowing has come, for example, 3 times here. So knowing, and every word we put a special symbol saying that end of the word. So this is a special symbol. So knowing has come 3 times. The is only one time. Name one time of like this something. Here only I want to emphasize that this something dot is different from this something. Okay, so here is something and where the word is ending. Here it is something full stop which is ending. So initial walkup size we get 16 in this. And similar, the same kind of question has been asked in the GA also is 16. Now with
Why
this,
something is the different from other two?
this is because this something is without this is something here.
Yeah.
It does not have a full stop here. So it is
Okay.
only something W. Okay.
Okay. Okay.
This something is full stop. So this is something dot and then full stop. Is that
Okay.
okay?
Okay. Yeah. Okay.
Okay.
Yes.
So from here, if you take, there are 16 words in this. So we get total count of 16. But the walkup size is, sorry, this walkup size is 13 only. Okay. Can we make out? The second step is now, we now do the character level. We go to character level. Okay. So now we start with K, N, O, I, W, I, N, G. And we keep on writing their occurrences, accounts. So you realize this K has come only in knowing. And how many times it happened? 3 times. N has happened so many times. So you do in all words. Okay. Similarly, you do for this end of the word also.
Sorry to interrupt. So N means number of times the word count, like 1 to 13 you count. N.
Number of the times N has come. So what do you do? For example, I take knowing. So N came 3 times. So first three,
Yeah.
second 3 times, three.
Okay.
Is that okay?
Okay.
Then you came to name. So name has happened one time in name, N is there.
Mm.
Then you come to something. So N is there 2 times in that.
Yeah, because there are two somethings, right? That's what.
Yeah. So it is like the character level you're doing.
Okay. What if there was a word like at number 5, something instead of something, there's a word which has two N's. So 2
Okay.
into 2.
So you will increase that 2 into 2.
Okay. Got it.
Okay. Okay. So this is straight away, nothing again. You are just
We
counting
we
the
just need to
characters.
count. Yeah. We just need to
Yeah.
count
Okay.
them.
Got it. Makes sense. Yeah.
Yeah. Okay.
Sir, the
So
initial vocabulary is created using means by separating, splitting using the space.
yes.
So 1 minute, just scroll up. So if is there a space between something dot knowing
Where?
here in the sentence?
Just I will
Something
copy.
full stop knowing. Is there a space between them?
Yes, there is a comma. Okay, just hold
Okay,
on.
comma. Okay. So if there was no space between like something comma
Okay,
knowing.
okay, just a second. Hold on. I will
Hmm.
explain here. This is the full stop here. Okay.
Hmm.
So how many words you have got? You have got knowing, full stop, first,
Hmm.
the, full stop, name, full stop, of, full stop, something, full stop, is, full stop, different, full stop, from, full stop, knowing. So now this knowing which has come, it has become 1 plus 1. Now something dot, this something dot is different from this something. So this something dot is a separate word. So this becomes something dot w. This is
What
one.
I'm asking is something dot knowing. Is this continuous means there is no space anywhere, or is
No,
there
no.
space like something
This
dot space
this
knowing?
this dot after that dot, this
Hmm.
dot is considered okay and okay. So there is a space here.
Okay. Okay.
Okay.
Got it.
Okay.
Got it. Okay. Yes. Okay.
Okay. So this is for the basic vocabulary. And once you do the basic vocabulary, you do the character level. So this is you get the character level. Is this okay? This part okay? We can do manually also, or we can write a simple Python code and we can find out. Is that okay till now?
Yeah.
Okay. Now the second okay, now we go to the pair count. Now the character level okay, pair count. So this is the first basic vocabulary which remains secure. Okay, so this is a basic vocabulary. When you are building vocabulary, so everything whatever you have built here, everything has come. Okay, so we have got okay, how many? Like 22 words we have got, and in this 22, if you find out this isn't in the isn't, there is a this apostrophe. So this is also there. Full stop is also there. Okay, so there also, and the end of word is also there. So these are the three special characters. Okay, now we go to pair count. So we start here from every pair count. So in knowing, we know we'll start KN, NO, OW, WI, IN, NG, and G, end of the word. Is this clear? This part?
Yes.
Okay. Then we go to the second, the. So THHEEW. Then name, NAANME, end of the word. Then off, OF, F, end of the word. So something. So in the something you will realize that SOOM, they are the new pair words, but ME is already there in the name. So ME you will add here. So like this, you find the pair counts, byte pair counts. And when you do the pair count, so you will find the frequency of sum. So for in this example, IN and NG, they have got frequency 7. So what do? We take the first occurrence. We will take IN and we make a new count IN. So what I had covered till now here, that we made a vocabulary of every character which we found. Now we will add whatever it was there. We will also add in this, and this count of I and N which is there. Now this is 7. I count here was how much? 10. So this I count I will reduce minus 7. And N also, there is N here, must be downward. So N also I will reduce the count. Is this okay? this step with everyone?
Why are we choosing IN?
IN we have chosen because its frequency is the maximum. It
Okay,
is
okay.
7 7, everything is
Yes.
less, and we select the first one. Is
Okay,
that
okay.
okay? Is
Yes.
this Muskan?
Got it. So basically, in the second step, you're just making pairs with like K, N, O, W, N, O in the
Yes.
order you were given in the sentences.
Yes, yes.
Okay, thank
And in case of a tie, we are selecting the first one.
you. Got it.
Okay, so this is the first step. Sorry, third step. Now remember here that if this n was 7 also, and if this occurrence becomes 0 also, then also we retain these occurrences. Okay, we retain this vocabulary which is there. Is that
Okay.
okay?
Okay.
Now what we will do the same exercise now, but now we will treat this in as one token. Okay.
Yeah, got it.
Okay. Yeah. So now see, now byte where count when we do, so here we will get, for example, in we got 7 times. We reduce n 13 minus 7. I we reduce 10 minus 7. So these are the counts. We use in as a single token now. Now when you do the single token, so again, now what you will get, if you go, this ing which is there, it will happen 7 times. Why it will happen? Because knowing was there 3 times, it has got ing. Something was there 2 times. Something dot was there 1 time, and everything was there 1 time. So this ing. So again, I will get this 7 times. Is this okay?
Yes.
So now what I will do, this vocabulary which is there, earlier I got IN. Now I get one more token as ING. Okay. And
Yes.
ING from where did I get? I got from IN plus G
So that's also like byte pairing.
byte pairing. So what I will do, this IN occurrences which are there, I will minus 7, and
Okay.
G also which is there, it will also minus 7. Is that okay?
Yeah.
And in case this becomes 0 also, then also I retain G. Okay, so that's how in every merge my vocabulary keeps on increasing. Okay, here I got in, here I got ing, here I can get something hing, here can get thing. So your vocab size which is there, it is proportional to your number of merges. This is the concept in byte pair encoding. Is that okay?
Yes.
Okay. So now it keeps on going. And like they have given an example that what happens after 45 merges. So after 45 merges, your initial vocab is there, then in came, then ing came, and you keep on increasing. And after 45 merges, this is your vocab. And your size of vocab, I already have told you, it depends on how you do the merges, number of times of merges. Now, what happens? How do you build a care? For example, now you've got a vocab. Now, how you will tokenize that? So they have given an example that you have built an vocab, for example, this, and now you are passing something hello lol. Okay, so what will happen? Break down this L L O L O L. So you pass this in iteration one through the vocab. So once you pass through the vocab, what will it encounter first? It will encounter LO. Is that okay? So it will get H E L L O LOL. Is that okay? There's a similar question in the GA also.
Yes, got it.
So this will become your tokens for this sentence. It is a simple example. In reality, it doesn't happen, but this is just to illustrate. Okay,
Want we merge HE?
because it is not there in vocab. Okay, sorry. So this
Yes.
is the this is the first iteration one. Okay.
Okay.
Now iteration two. Iteration two, when you will pass, now what will happen? HE. Okay. L L O and LOL. Is that okay?
Yeah.
Okay.
Yeah. Now, here only I want to cover that this tokenization which is happening, it is deterministic. Deterministic means, for example, if I change the vocab is equal to A, B, C, and here I write, for example, HE first, and then LO. So I will get the same result, but in the first iteration, I'll get HE first, and then I'll get LO. So there is another slide which I'll be sharing, that why do we want sentence piecing. So this is clear. Okay, how do we build? Okay, so with this I have covered the byte pair encoding. Any question till now?
I just have one question. Why didn't we go
Yeah.
in the first iteration? We counted he and hello.
Okay, so what happens, we are doing iteration wise.
Okay.
So when it encounters, I am passing this hello lol.
Mhm.
So when it will go, so it will first encounter hello.
Okay. Yeah.
Okay, so it will form like a hello. Then when second time I pass, okay, will pick up HE. It can happen in the same iteration also, no problem. But remember, this LO will happen. For example, if I had a case A, B, C up to Z, and there is a LL, LO, HE. Now what will happen? I'll get a different. So
Yes.
now
The
this
first one will be LL.
yes, okay.
Yeah.
So that's how you can get a different tokenizers. How you pass them through the vocab and what is the vocab content.
Got it.
Okay. So, from the quiz point of view, I'm covering this because there might be a question on this byte pair encoding. This will be a simple example like the GA, but we should be able to hack it. Is that okay?
Got it.
Yes.
Yeah. Okay. Good. Very nice. So then we come to the next sector. We come to word piece. In the BPE, what we did, we were merging the pair which was having the highest frequency. So in word count, word piece, what we do, we don't merge the highest frequency. What we find out a score. And a score, for example, a score of IN is count of IN divided by count I divided by count N. So that we select. Okay. So in this only from the previous example, these were the counts, these were the frequencies. So what we did, what we selected IN, the first one with 7. However, when we use the score, then you will find out the score of this AD is the highest because the score of AD will be 1, and you find A and D. We are done here. A was 3 and D was 2. So A and D is 6, which is the highest. Rest everything is lower. So that's why we select AD. So this is the only difference between BPE and word piece. In word piece, we use score.
So in WordPress encoding, we'll use AD instead of IN.
Yes, yes,
Okay.
yes. Okay.
Yes.
So your next token will become AD. Okay. And then we come to the this I have covered. So this is the AD, okay, for example. Okay. So 1 by 6, okay, I calculated, this becomes 0.16. Rest everything is lesser than. Is that okay till now? So we have covered BPE and we have covered word piece. Now we come to the last part of the word file, which is sentence piece. So why, first of all, the motivation behind sentence piece? Why we want that? The motivation behind that is that, like I said earlier, that in the BPE, it is greedy and it is deterministic. Like whenever you pass, you're going to walk up, definite walk up, and whenever you are passing a statement, it will give you the same result at every time. So it is greedy and deterministic. The second is we want to have a probabilistic approach to find the subword sequence so that it maximizes the likelihood of the word X. So I'll come skip this theoretical part. I'll come to the practical part. One okay. For example, there is a word okay. For example, X is knowing, and we know that. For example, he has taken that we can form this in three ways. So first way is K now ing. This is the first. Second is no ing, and third is complete knowing. Pardon my bad handwriting. So what we do, we find the probabilities of all these three sequences. One, two, three. Just give me a minute. I think I got a guest at my home.
Hey guys, the
Oh,
quiz to syllabus is 5 to 8, right? Not 1 to 8.
yeah, 5 to 8, 5 to 8. But 1 to 4, all the concepts which are there, they will come handy.
Yes, yes, yes. But
Oh yeah.
not no problems from 1 to 8, right?
Problems will not be there, but again, we should know what is the meaning of embedding matrix, how it is
Yeah, yeah, yeah.
calculated. Yeah,
Yes, yes.
okay.
Okay.
Yeah. Okay. So now what we do, for example, here we said, okay, it can be have oh, three sequences. So we find the sequence of this probability of this K, now, and Ng. So this will become probability of K, probability of now, and probability of Ng. So this becomes this. Then we find the probability of the second and the third probability. Whichever is the highest, we use the that will be there.
Why is
Another
K
example. Yes.
C means the frequency of amount of K appears, right?
Hi, you're not audible. Actually, your
No,
voice
sorry,
is
sorry.
not
Yeah,
clear.
I answered my own question. Sorry, thank you.
Yeah. Yeah. Are you saying something?
No, no, please continue, please continue.
Yeah. Thank you. Thank you. Thank you so much. Okay. So this was an example. And second example he gave from this whereby that how we build. So, for example, this whereby is there. So we start from where or top. So first we start from W, and W can have H or it can have WH. These are the probabilities which are coming from the corpus. And why do we use log? Because probability of xy is equal to probability of x into probability of y. So by using log, what happens? We are summing this plus log of py. So here you take the log. So at every step, what we keep on discarding. For example, here is WH. So this is minus 7.63, and from where it has come? It has come from W log and H log. H is minus 3.34. So if you add this, you get minus 7.63, whereas WH is minus 5.5999. So this you select. At the second step, when you go WH, WHE. And once you have done WH, you have discarded, you will not go further because I know that its probability is lesser. So at this point, WH and E this probability is higher. So at every iteration, you keep on adding and you keep on finding the probability. So WHER in this case. Then WHERE is minus 14.03. However, if you do straight away WHERE, its probability is minus 8.21. So you select this, it is higher. And finally, you come to where B. There's only a slight mistake in the slide which was covered by the instructor. At this place where B and Y, where he stopped here, there is a Y also here. And if you add this Y, this probability will be more than around minus 16, less than minus 16. And that's why you select whereby. So this is minus 15.51. So here this slide has an error. And the last part is the Morpheser algorithm, which uses a maximum of posterior MAP estimation. So it is not there, like it is not being covered extensively. So I don't expect from the quiz point of view. So with that, I have covered the theoretical part. Any question in that before we move to the graded assignment? Anybody wants to give any input? Abir, good evening.
Hello, sir. Good evening.
How are you? Long time.
Yeah, sir. It's been a long time. Ashutosh told me that you're taking a session, so I hopped in immediately.
Yeah, thank you.
Can't
Thank you
miss
so much.
this.
Yeah. So anybody wants to give any input, any question before we jump to graded assignment? Anand, Raja, Rituparna, Shubham.
I have doubt in graded assignment only.
Okay, okay, okay.
Okay,
So
let's start with the GS.
yeah. So give me 30 seconds, please. Okay, this is the first question. What are all the challenges one would face while building a vocabulary from a large corpus of text? Assume the corpus contains only an English text. So we have seen, we have got the challenges deciding the size of the vocabulary, method to handle unknown tokens, handling misspelled words, handling names and numbers. For example, if this number has come and which was not there. So these are all four challenges. Is that okay?
Okay,
Then we
see,
saw, yeah,
hello, I have a question here. So I was
yeah.
asking, so when I read the fourth point here for a moment, the handling names and numbers, I was confused. So suppose anyone's name, Rahul, Lalit, or your name or any. So do we really need to tokenize you can say proper noun?
See, that is a problem if we are directly taking from a corpus. Okay. In the corpus, what we are doing, we are using only the white spaces. Now, for example, take this example. If this number didn't come earlier and it suddenly has come, how it will handle it? So it will treat it as a like an unknown.
Yes.
Okay. And that is a challenge. So this unhandled unknown tokens, it is similar to handling names and numbers.
So yeah, but one of my doubt is suppose I don't remember any example, but uh, a, f- a few names might have another pronoun or something in their name. So when you when the model might try to subtokenize it, it may read different relations. You getting my point?
Yes, 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 yes. So there is, but again, they have said in the question that they are building from a large corpus.
That's right.
Okay. So in the large corpus, almost all of the words they come. But the problem will always come about the numbers.
Okay.
And something can be treated as an unknown also. Okay?
Okay. Yeah. Okay. Yeah, I got.
Yeah. Yeah. Okay. And second question is select correct statements regarding the character level. So in the character level, what we had realized that in the character level, our walk-up size, which will be very small, first of all. Okay. It will have A, B, A, B, A to Z. And if you are not normalizing, then A to Z, 0 to 9, and some special tokens. So it is very small, first of all. So what he has said, the size of the vocabulary by character level will be large. That is not true. It will be very small. Second, computing softmax probabilities will be easy. So if your walkup size is small, always finding softmax is easy. When it starts increasing, your finding softmax becomes difficult. The third, the vocabulary will not expand if the new words like sentences are added to the corpus. That is true because it is character level. So whatever the sentence word comes, it will remain the same. And no issue of handling unknown tokens. Now in this anything comes, it will be handled. Is this okay?
Can you explain the third point a little bit?
Okay. So see, the third point is like that. You have got A to Z, A to Z, 0 to 9, full stop, apostrophe, special symbols, all are there. For example, now you got. Now, whatever the new sentence comes, for example, it comes Rama, Krishna, Paramhans. It can be put it here. You can,
Yes.
okay, you give anything, avocado, Jupiter,
Mm-hmm. Yes, got it.
Jupiter. Okay,
Yes, yes.
so it can be handled. Whereas okay, if you build on the white space, the unknown words cannot be handled. Here it can be handled. Okay, so now we go to the third part. For which of the following options applying BPE based on white space delimiter is not feasible? So BPE, we had something, this delimiter space.
Yes.
Okay, so it means the BPE needs this. Okay, and if you see all the options, it has got a white space, this has got a white space, this has got a white space. Japanese language, they don't have any white space. Okay, so here the your BPE cannot be, is not feasible.
Right. Okay.
Okay, yeah. Now we come to the next part, which is directly from application of BP. So this is your corpus, low 4 times, older 5 times, finest 6 times, lowest 7 times, loneliest 8 times. Append W to each word at the end. You'll be learning a byte pair encoding, BPE. Answer the following questions in that context. How many tokens are there in the initial vocabulary? So what do we do for the initial vocabulary? How do we do that? We find, for example, L. L is there. 4
Okay, I
times
got
it has happened here.
Yeah.
We come to O.
5
O
times.
4 times. 4 times, no?
Yeah, for low it's 4 times. Yeah. Okay.
Yeah. So we are going character by character. L O
Okay.
W. 4 4 4. Add the end of the statement 4. Now we come here older. So O is there. So we add 5 times. Then L 5 times. Then D. So D is a new word, a new character, sorry. It becomes 5 times. E is a new 5. R is a new 5. W. So here is a W. We add 5. We come to finest. F 6. I 6, N 6, S 6, T 6, W we add 6. Now again come to LO. L 7, O 7, W is already there 7, E is already there 7, S is already there, T is already there, and W is there, so 7. Then similarly we do for loneliest. So this is your initial walk-up size. So has everybody understood this part?
Yes, sir. Sir, in BP, first we start with character level, then we go on merging.
Yes.
Okay, sir. Thank you, sir.
Yeah. Okay. Now, second, okay, now he asks, which of the following pairs has the least frequency before any merge? So what we have to do, we have to come to the step 2. This was step 1. And step 0 was what? Word wala, right? Words. This is the initial vocab. So now what we will do, we will start with, so I have written down here. So this is the one. Now we come to the second part. So we start with LO, OW, WW, OL, LD, DE, ER, RW, FI, IN, NE, ES, ST, TW. And whichever is getting repeated, you keep on adding that. For example, this LO is here also, and here also. So 4 plus 7 plus 8. So once you'll get the numbers. And when you take the choices, so you see WW here, WW is 4. LD is 5. IN is 6. So you get the answer. So have you been able to understand this? We can do this. It is easy.
Yes.
Yes.
Okay, good. Then he has asked, what's the most frequent byte pair before the first merge? So we go here and we find out. So what is the most frequent? ES and ST and TW. And what we learned? That we do the merge of what? The first. So we'll do the merge of what? ES. Is that okay?
Yes.
Yeah. So ES, answer is ES, and they have then asked the frequency. So this is 21. Then he has asked how many tokens in the vocabulary will have their frequency revised or reduced after first merge. So we have selected ES. So what will happen? किसका हम क्या रिवाइज करेंगे? E का और S का?
Yes.
Okay. So E and S okay, will revise. So initially we had okay, this vocabulary. In this vocabulary, now we will add ES also. And now ES, for example, is 7 plus 6, 13 plus 8, 21. And 21, E minus 21. And S minus 21. So see, this S becomes 0, but it will be retained in the vocabulary. Is that clear?
Yes.
Yeah.
Okay.
Okay, good. After the first merge, how many tokens are there in the updated vocabulary? So we had how many here? We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And now we get a new token. So now how many are there? 30. Okay. Every merge, remember this is a, I can say, thumb rule. Initial walkup size plus number of merges. So you can say n. So after first merge, 1 will increase. After 2, 2 will increase. So this is the thumb rule. Is that okay? Next question is, suppose the process of building the vocab stopped after 7 merges. The following is the list of 7 merges. So you can see here also 7 merges. First merge ES, second EST, ESTW, LO, LOW, LON, and LONE. So these are the new tokens which have been added to the vocab. Now they are saying that we pass the word finest and W be tokenized. So how it will be tokenized? Can somebody solve this? Anand? So we are passing finest and it has got a W also. And what is your vocab? Vocab was initial all the characters which are there. It had F also, I also, N also, E also, S, T also, many characters. And then it has got ES, EST, EST, W, LO, LOW, LON, and LON. So, like I had covered in the first iteration, what will happen? First, this finest which is there, you break into characters F, I, N, E, S, T, and W. Is this okay?
Yes.
Step 1.
Mm,
Step 2, pass through vocab. So what will happen? This FINE which is there. So first it will encounter this.
yes, you're right.
So FINESTW.
Yes. Next step it will be ST.
Yes, very good. Next step it will become FINESTW. Next it will become FINESTW. And after this, there is no change.
Right.
So this is the answer. Okay. So can all of us redo this again? Question?
Yes.
Ashutosh?
Yes, sir.
Yes, sir.
Yeah. Yeah. Okay. So this was the last question. Okay. So with this, I have finished this week 5 important concepts. If anybody wants to ask me anything, please pipe up.
I guess we're good. Thanks.